Dear students, we have discussed the Pythagoras theorem in our earlier classes and you have understood it. On the basis of the Pythagoras theorem, we are going to solve some of the problems. There are many problems. Among those problems, we have written one problem on the board. It's like this. Let us read it out. In the right angle triangle ABC, it is given that there is a right angle triangle ABC. So angle B that measures exactly 90 degree. Two sides value BC is given 24 centimeter or 24 units, and AB, the height of the triangle, it is given 7 centimeter or 7 units. You may take centimeter, meter, kilometer, whatever the millimeter, isn't it? So if it is unit, it is according to your desire. If it is given centimeter, it is centimeter only. Okay, fine. So these two sides have been given here in the question. We have to find out the value of AC, isn't it? To solve this problem, we have to use the formula of the Pythagoras theorem. Yes. Can any one of you tell me what is the formula of the Pythagoras theorem? Yes, from this side I expect. Yes, anybody? Stand up and tell me. Yes, Arsha. Just remove your mask and say what is the formula of Pythagoras theorem.
AC square is equal to AB square plus BC square.
Okay, that's good. You could have told this without seeing the board. It's okay, no problem. Solution, we have the formula that is AC square is equal to AB square plus BC square. This is a very fantastic formula. You can use it for many of the problems. See, the value of BC it is given, that is 24 square. The value of AB that is given, that is 7 square. What we have to find out? We have to find out the value of AC, isn't it? The square of 7, that is 49. The square of 24 we have to multiply. So that is 576. If we add both of these values, then it will be 625. So the value of these two is 625. So we have AC square is equal to 625. So the value of AC is equal to square root of 625. The value of AC, that will be plus or minus 25. We take only the positive value. So the value of AC is how much? 25 centimeter. So this is the very simple problem in this Pythagoras theorem. You need to understand this very nicely. If you understand how to use this formula in the question, you can solve the remaining problems which is there in the textbook. Come on, let us solve the next problem. Yes, dear students, we have another question. Question number 2. It is also there in your exercise. The exercise number in the textbook, that is exercise 2.5, 9th question. Sorry, 12th question. This is also the question in the exercise 2.6 in this chapter 2. So that the question is there like this. There are two poles of height 6 meter and 11 meter on a plain ground. The distance between their feet is 12 meter. One pole is of height 6 meter, another pole is of height 11 meter. Distance between two poles, it is 12 meter. So we have to find the distance between their tops. Let us write this question in the diagrammatic form. So this is the ground. Let us consider AB is 1/4. The height of this pole is 6 meter. And we have another pole. Let us consider this is CD. The height of this pole is 11 meter. So the distance between two poles, that is 12 meter. The distance between two poles, it is 12 meter. They have asked to find out the distance between their tops. So A and C are the tops of the two poles. The distance between the two tops, that is AC. Directly they have asked us to find out the value of AC. Finding out the AC is very easy. See here, we have the value of AB here. So let us mark one point, that is E. The DE is equal to 6 meter. Let us join this AE so that AB is equal to DE. The value of DE it is given 11 meter. The value of ED is 6 meter, it is there. Then the value of CE will be 5 meter, because if we subtract 6 from 11, 5 remains. That is the value of CE. And the value of BD is 12 meter. The same value will be there here for AE, that is 12 meter. BD is equal to AE. So we have AE is equal to 12 meter and we have CE is equal to 5 meter. The triangle ACE is the right angle triangle. By using the Pythagoras theorem, AC square is equal to AE square plus CE square, we can easily find out the value of AC. Come on, let us solve this. Solution. In triangle AEC, so AE is equal to BD is equal to 12 meter and CE, that is equal to BC minus DE. BC, that is 11 meter and DE, that is 6 meter, so that is 5 meter. We can easily find out the value of CE, and the value of AE is also already there. So AE, CE, both the value we have got. Then by using Pythagoras theorem, so AC square is equal to AE square plus BC square. So AE in the sense that is 12 square, CE or EC in the sense that is 5 square, 12 square in the sense that is 144, 5 square means that is 25, 144 plus 25, that is 169. AC square is equal to 169. AC is equal to square root of 169. Then the value of AC, that is equal to plus or minus 13. We take only the positive value, so that the value of AC is 13 meter. This is how we need to understand the question very first, and we need to analyze before writing the answer. We need to analyze the question at the very first thing, and then if we analyze the question very first, then it is very easy for us to find out the value of AC. So this is how we have solved the second problem, that is 12th problem in exercise 2.6. Come on, let us see the third problem. Yes, dear students, we have reached for the third question. The question number is like this. This is also the question in this is actually the third question. But ninth question in the exercise 2.6, the question is like this. Ladder. What is the meaning of ladder? Ladder 10 meter long. The distance of the ladder is how much? 10 meters. Okay. Reaches a window. Where is a window? Window 8 meter above the ground. I mean, you have to understand there is a wall. So in this wall there is a window. So this window is 8 meter height from the ground. So there is a house like this. Okay. In this house we have a window. So the window is of height 8 meter from the ground. Isn't it? And a ladder of 10 meter long. So this is the ladder. The length of the ladder is 10 meter. Height of the window above the ground is 8 meter. So we have to find the distance of the foot of the ladder. Foot of the ladder is this. From this base of the wall. So this is the wall and this is the base. So what is the distance of what is the distance from the base of the wall to the foot of the ladder? This is what we have to find out. So by seeing the figure itself, we have understood how to find out the value of this distance. Okay. Let us name this right angle triangle P Q R. Okay. So what is the formula for this triangle PQR? Who is going to tell this? From this side I expect. Yes, come on.
QR square.
Remove the mask.
QR square is equal to PQ square plus PR square.
That is absolutely wrong. Isn't it? Yes, who is going to correct this? Yes, Prasad.
PR square
Remove the mask.
PR square is equal to PQ square plus QR square.
Yes, exactly right. Okay, you are coming into the form. Please sit down. Let us write the solution in triangle. This is actually in the shape of triangle. This is not the triangle. If we put the ladder to the wall, then wall to the ground will be always 90 degree. You know that. And the ladder will be like hypotenuse of the triangle, isn't it? So PQR is an imaginary right angle triangle. So in this imaginary triangle PQR, we have the distance of the window from the foot of the ground, that is PQ is equal to 8 meter. Distance of the foot of the ladder to the wall, that is what we have to find out. QR is equal to how much we have to find out? Yes. Length of the ladder PR, it is given, that is 10 meter. So PR is equal to 10 meter. So we have to find out this QR. To find out this QR, we have to use Pythagoras theorem. So Prasad has told that the theorem, the formula of the theorem, that is PR square, that is equal to PQ square plus QR square. So the value of PR, it is given, that is 10 square. The value of PQ, it is given, that is 8 square. We have to find out the value of QR square. 10 square, that is 100. 8 square, that is 64 plus QR square. This 64 will go this side and it becomes minus 64. So 100 minus 64, that is equal to QR square. 100 minus 64 in the sense 36. You can tell loudly. Then if QR square is equal to 36, then what is QR is equal to? Therefore, QR is equal to plus or minus 6. We take only the positive value. Then the value of QR is 6 meter. The distance from foot of the ladder to the foot of the wall is 6 meter. I hope this problem is very easy for you. Not only these 3 problems, almost all the problems if you see in the textbook, which are easy like anything. So all the 3 questions what I have solved on the board, you felt it is very easy. Am I right? Am I right?
Yes, sir.
Whether it is very easy for you or difficult for you?
Easy, sir.
I come to know today that the way in which you have sit here and listening here, if it is there for every class and for every subject, then every problem will be easy and every subject will be easy. So this is how, this is why I just wanted you to tell you, listening is very important. Since there is a video here, it is recording, you are completely alert that there should be no disturbance for this video. You have kept everything in mind and you have been listening. Since there is an alertness for you recording video, you are listening it very clearly and very nicely, so that you can understand it, these problems very easily. Not only these 3 problems, almost all the problems which is there in the exercise 2.5 are easy like this thing only. From today onwards, what I just want you to do is that listen carefully. You will understand it very neatly. You have understood these 3 problems. You go home today and rate it for 3 times. One, understand the problem what we have understand. We have to write it for 3 times. It will be there in your mind. It will never be forgotten in the future. So not only this, whatever the problem it is there, I tell you very neatly. You know that I am teaching very neatly, but I know that you are also listening the class very neatly in the future. Please listen. I wish you all the best. Yes, dear students, we have another question, that is 4th question in the chapter triangle. We have exercise 2.5. In that exercise, this is the very first problem. So this problem tells you about the Pythagorean triplets. Pythagorean triplets in the sense, you have to remember very neatly that if there is only a right angle triangle, then you can apply the Pythagoras theorem. If there is no right angle triangle, if there is a Pythagorean triplet, if you apply it, it won't work. So here there are 3 set of sides is given. These are the sides of the triangle. Okay, these are the sides of the triangle. So if the square of the hypotenuse is equal to sum of the square of the other 2 sides, if it is equal, then that is a right angle triangle. If it is not equal, that is not a right angle triangle. So I tell you one remaining problems you need to find out solution. See here, 7 cm, 24 cm, 25 cm. Which is the greatest number here?
25.
So here you have to write 25 is the hypotenuse and 7 is side of one. 7 is the one side of the triangle and 24 is the another side of the triangle. So if 25 square is equal to 24 square plus 7 square, 25 square, that is 625. 24 square we have solved just now. What is the value? 576 plus 49. These two will be 625. This is equal to 625. Then what 3 sides are given these are the sides of the right angle triangle. So this is the left hand side is equal to right hand side. So these are the three sides which are Pythagorean triplets. Find out which is the highest. 8. 8 square is equal to 6 square plus t square. If LHS is equal to RHS, then it is Pythagorean triplet. If not, this is not a right angle. Like that, will you do the remaining two problems? Can you do it?
Yes, sir.
Yes, sir. This completes the class today. Let us discuss the remaining problems in the next class. Thank you.